Welcome to our mathematics class. Today we're going to study polynomials. And in polynomials we're going to look at the addition, the subtraction, multiplication and division of polynomials. Then we will also go further to look at the remainders theorem in polynomials. Then finally we shall look at the factor theorem in polynomials. Then we will now look at how to solve problems in polynomials. So you're welcome. Our topic today is polynomials. Definition: an expression of the form a0, this is a subscript, plus a subscript 1s plus a subscript 2s squared plus ellipsis dot 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 plus a subscript n s to the power n, comma, where a0, a1, a2, and then up to an are numerical constants. And of course, an not equal to 0 is called a polynomial of degree n in S. This is denoted P of S. That the degree is the highest power of the variable S. Product of a polynomial Sm times Sn will be equal to Sm plus n. Recall the laws of indices. You add the powers where the base is the same. Or we can write this as s raised to the power n plus n. The degree of the product is n plus n or n plus n. Quotient of a polynomial. Sm divided by Sn, where n is less than n, will be equal to s raised to power m minus n. The same laws of indices, division law. The degree of the quotient is m minus n. I want you to note this. If a polynomial Ps is divided by another polynomial b of s, the result will be equal to q of s, which is the quotient, plus the remainder also of s. Sometimes this remainder of s can be a constant. It can also be a algebraic expression. That's why we're leaving the s there. It can just be a constant. It can also be an algebraic expression. Therefore, our Ps will be equal to, if you cross multiply, d of s times q of s plus the remainder. Take note that we are not multiplying the remainder by the divisor. Let's look at the types of polynomials. Number one, linear polynomial. As minus 2 is an example of a linear polynomial. The degree of this polynomial is 1. That is, the highest power of s here is 1. That is why it is also called a linear polynomial. Number 2, quadratic polynomial. An example, 2s squared minus 3s plus 1. These are specific examples. In a general form, you can write it as as squared plus bs plus c. The degree is 2. Number 3, cubic polynomial. We have an example here, s cubed minus s squared plus s minus 48. The degree here is 3. Number 4, quartic polynomial. We have s to the power 4 plus 2s to the power 3 plus s minus 1. The degree is 4. Sometimes one of the variables, the degree can be avoided or is not written. For example, in this case, there is no s squared. So we don't have a value for s squared. That does not say that this polynomial is not of degree 4. It doesn't affect it. Number 5, we have the quintic polynomial. And I'm writing this as 1 minus s cubed plus s raised to the power 4 plus s raised to the power 5. The degree is 5, the highest power of s. And you see now that the powers here are in ascending order. I also have the first case of the quantic, or the former ones I've written, they were in descending powers of s. This one is in ascending powers of s. Observe that polynomials can be written in ascending or descending powers of, say, s, where s is the variable that we are using or is in use. Thus, the polynomial s will be equal to s cubed minus s squared plus s minus 48. Is in descending powers of s. Take note of that. The powers are descending from 3 to 2, 2 to 1, and 1 to 0. And if the polynomial p of s is equal to 48 minus s plus s squared minus s cubed, this one is said to be in ascending powers of s. You can see now that the power of s here is 0, the power of s here is 1, the power of s here is 2, and the power of s here is 3. We are now going to look at the operations on polynomials: addition, subtraction, multiplication, and division of polynomials. We shall do this by solving examples. Number 1, giving the polynomial 5s squared plus s plus 1 plus, in bracket we're going to close this, 3s squared minus 3. We are told to find the sum of this polynomial. Our solution, you have your 5s squared plus s plus 1 plus 3s squared minus 3. I have opened the brackets. I will now collect my like terms. I have my 5s squared plus 3s squared. I have my s. There's no other s there. I have my plus 1 and minus 3. The numerical constant. Addition, like terms. 5 plus 3 is 8 of s squared. And then plus s, and then 1 minus 3 is minus 2. So the polynomial that you get at the end will be 8s squared plus s minus 2. So the sum of that polynomial gives you this result. Number 2, we can also carry out subtraction, and then we have this result. Assuming I'm subtracting this from this, solution will be 5s squared plus s plus 1 minus 3s squared minus times minus will give us plus 3. We can now collect the like terms together. 5s squared minus 3s squared plus s plus 1 and then plus 3. The result of this will be equal to 5 minus 3 will give you 2s squared, and then we have plus s, and 1 plus 3 is 4. So therefore, our p of s is equal to 2s squared plus s plus 4. Example number 3. Multiply 5s plus 2 by s squared minus 1, all in brackets. Solution. We have 5s plus 2 times s squared minus 1. When the brackets are written like this, it means we are asking for, or it is the product, the multiplication of this by this. Now, in this multiplication, you remember our smiley face, where this will go to this, and then you have this, and this will also go, and then this one will also multiply this, the smiley face. That means we have 5s going into 5s squared minus 1. Then we have plus 2 going into s squared minus 1. And that brings out our smiley face, 5s cubed plus s times s squared. Then we now have minus 5s times 1, which is 5s. We now have plus 2s squared, and then we now have 2 again, multiplying minus 1, which is minus 2. So at the end, we have simplification, 5s cubed plus 2s squared minus 5s minus 2. So the product of this polynomial PS will be equal to 5s cubed plus 2s squared minus 5s minus 2. Or your PS is minus 2 minus 5s plus 2s squared plus 5s cubed. The first one is the descending order, the second one is the ascending order. Now, example number 4. This is under division. Divide 2s cubed minus s squared plus s minus 48 by s minus 3. Solution. First and foremost, you write your 2s cubed minus s squared plus s minus 48. You draw the line, a long division process, and you write the divisor. You observe that the degree of the divisor is less than the degree of the polynomial. The degree of the divisor is 1. The degree of the polynomial is 3. Therefore, division is possible. Now, the first thing you do is to divide the first term here by the first term here, the coefficient here. Sorry, by the term. The first term here, which is s. So you now have 2s cubed divided by s. By loss of indices, it means 1s will cancel one of the s here because we have 3s in this place. S. So we now have 2s squared. Now multiply this by this. So we now have 2s squared times s will give you 2s cubed. Then 2s squared times minus 3 will give you minus 2s squared. You underline and you subtract. Remember, this is long division process. If you take away this from this, it will be 0. So we have minus s squared minus 2s squared. And of course, minus 2s squared becomes what? Plus addition. So what happens? We now have minus s squared plus 2s squared, which will now give you 2s squared minus s squared. And the value here is equal to s squared. Now bring in the next value, which is s. So plus s. Again, divide s squared by s. So that will give you plus s. Multiply out s times s is s squared. And then s times minus 3 will give you minus 3s. Again, subtract. S squared minus s squared is gone. So we now have s minus 3s will give us 4s. Bring in your minus 48. Again, divide 4s by s to give you 4. So this is plus 4. multiply out 4 times s is 4s, and then 4 times 3 is 12. So we have minus 12 there. Again, subtract. 4s minus 4s is gone. Minus 48 minus 12 means minus 48 plus 12, and that is going to be minus 36. You discover now that the degree of this value here is 0, and the degree of the divisor is 1. As long as the degree of the divisor is greater than the degree of the polynomial, division is no longer possible at this point. So this becomes a remainder after you have carried out your division. So our answer is the quotient is equal to, so our answer is 2s squared plus s plus 4, and then remainder, let's say remainder 36 minus 36. Remainder minus 36. This is the quotient, and this is the remainder. We have the polynomial and we have the divisor. Note, our polynomial PS is 2s cubed minus s squared plus s minus 48, and is divided by our s minus 3, and then the result was equal to 2s squared plus s plus 4, and then remainder minus 36, which translates to saying our 2s cubed minus s squared plus s minus 48 is actually equal to the divisor multiplying your 2s squared plus s plus 4, and then plus the remainder, which is minus 36. That is what we wrote the other time to say PS all over BS is equal to QS and then plus ROS, which eventually is the same thing as PS equal to D of S times your Q of S and then plus the remainder, as we have seen above. That is the relationship. Example number 5. If P of S is equal to 2s squared minus 5s plus 3, find P of S plus 1. Solution. All you need to do in this case is replace S by S plus 1. Replace S by S plus 1 in the expression or in the function. So you simply write your P of S plus 1 should now be equal to 2. In place of S, I will now write S plus 1 all squared minus 5 and then another S plus 1 and then plus 3. This is all we need. Then we can now open up our brackets. This becomes 2. If you open this bracket, you have S squared and you have plus 2S plus 1. Close that. Then minus 5S minus 5 and then plus 3. If you open this bracket. Furthermore, we can open the first bracket again. 2S squared plus 4S and then plus 2 minus 5S minus 5 and then plus 3. You can now collect like terms, so that will be equal to, there's no like term to 2s squared, is on its own. Then we have 4s minus 5s, which will give you minus s. Then you have 2 minus 5 is minus 3, minus 3 plus 3 is 0. So the final answer is 2s squared minus s. Now take a look at example 6. If the polynomial of s minus 4 is equal to s squared plus 2s plus 3, find the polynomial of 2, P of 2. Now, once again, our solution, you replace s minus 4 and equate it to 2. That is, s minus 4 is equal to 2. In this case, our s is equal to 2 plus 4, and the value is 6. So we are going to now, anywhere we see s, we will substitute the value 6. Therefore, our p of 2 will now be equal to our 6 squared plus 2 times 6, and then plus 3. And this gives you 36, and then plus 12, and then plus 3. And the final answer here will be 51. And that is the value. Take note of how this has been done. It's a common question in most of the exams. Example number 7. If s plus 1 over s equal to 4, find s squared plus 1 over s squared. Solution. We have s plus 1 over s. If it is squared, we give you s squared plus 1 all over s squared plus 2. Making s squared plus 1 all over s squared the subject of the formula, we give you s plus 1 over s all squared minus 2. The result of this is 4 squared, because s plus 1 over s is 4. So 4 squared minus 2, and that means 16 minus 2, and then the final answer is 14.